Hello, welcome to EGME 441.
Thank you, Professor.
How are you?
I'm all right. How you doing?
Good. And how do I pronounce your name? Is it Anibesh? Is that
Yeah,
correct?
yeah, that's right. That's right,
Okay,
Doctor.
great.
Mhm.
Awesome. Well, welcome Anibesh. So it'll be I'll start at 4 o'clock, but if you have any questions for me about the course or anything, feel free to ask.
Not now, Professor. I haven't really gone through it. So once I go through it, I'll probably email you.
Okay, right, sounds great.
So just one quick question, Doctor. Is the class going to be online every day or just for today?
I'll have the Zoom link available every day, and so
Uh,
if you prefer to attend the lectures virtually, that's fine with me.
okay.
The only days that I do ask that you be in person will be for the exam days. And so for the exams,
You mean
those
midterms?
the midterms, yes, the midterms will
Yeah.
only be available in class. Yeah.
Okay, I see. Professor, just a quick question. I was going through the course description. So I see that there is a final project at the end of the semester. Can you explain like what sort of project it's going to be like? How would I be able to submit it?
Yeah, no, it's a good question. So the final project is a group project, and we'll talk a bit about it today. But
Mhm.
this is mostly just kind of an introductory course in biomechanics.
Okay.
I try to do kind of I try to cover all the basics and kind of give you a broad overview. But I think a lot of people come into the course with kind of interest in kind of specific areas of biomechanics, whether it be things like prosthetics or things like bio-inspired design, things like that. And so the final project is kind of your chance to kind of explore those areas and kind of apply those kind of what we learned in the class to kind of those more specialized topics. So it's kind of more of a research kind of project. And so it involves kind of looking up research articles, doing some kind of individual calculations on your own. And then at the end of the course, you're going to present it in kind of a final presentation and write a final report.
Oh, I see. That sounds interesting.
Mhm. All right. It's 4 o'clock, so let's go ahead and begin. All right, welcome everybody. It's our first day of the fall semester in EGME 441. So my name is Justin, Professor Justin Tran. So I will be your instructor for this course. So first of all, I want to say thank you everyone for meeting virtually today. Hopefully the hurricane is not too bad where you are. Actually, where I am, it's actually very sunny and beautiful. So it seems odd that I'm taking a work from home day when it's so beautiful outside. But I know other parts of California, I know it's very wet. And so hopefully everyone's staying dry. Hopefully everyone's staying safe. And yeah, glad you could be here today. All right. And so for those of you who are just logging in, so my name is Professor Justin Tran. And so today is the first lecture for EGME 441, Engineering Biomechanics. And so the plan for today, or at least kind of what I had planned was, I'm just going to basically just introduce the course, talk about the syllabus, talk about the course policies and expectations, and then we'll take a tour of the course website because I think that is kind of the extent of what we can do with the you know virtual stuff. Can everyone hear me, by the way? I'm seeing my mic isn't really going off.
Yes, Professor.
Okay, good. Okay, great. All right, so I'm going to go ahead and start the slides here. And so if you have any questions throughout today, definitely feel free to ask. That's I was going to say something, but I forgot. So if I appear sleepy, I'm really sorry. So I was actually in Europe yesterday, and I just got back at midnight. So I am pretty fucking jet lagged right now, and so I'm pretty tired. But that's why I was definitely not unhappy to hear that we canceled in-person classes, so I didn't have to drive today. And so, but if I appear sleepy, I apologize. But I'm going to do my best to get them today. Okay, so let's go ahead and get started. Okay. So let's start with the learning objectives. And so, this will be something that you'll see pretty constantly throughout the course. So these are things that I like to do to kind of start with every day. And so at the beginning of every lecture, what you'll see is a list of learning objectives, which you can kind of think about as kind of like an outline for the day. And so for today, we're going to introduce the course, and we're going to define what biomechanics means. We're going to talk about some engineering applications of biomechanics, and we're going to prepare for the semester by looking at the course policies and expectations and the website. Okay. So what I always tell students, and at the beginning of every course, at the beginning of every lecture, I definitely recommend that you write down the learning objectives for the day, just to kind of give you kind of an outline and an expectation for what we're going to cover for today. And I write these learning objectives very intentionally. And in fact, what you'll notice from all of these is that they start with a verb, right? And so I write these learning objectives in a way to kind of describe something that you should be able to do at the end of the lecture or at the end of class that day. And so this kind of serves as a kind of a good way for you to review kind of if you understood everything from the lecture, right? Because I remember when I was a student, I would go to lecture and I would always question, it's like, yeah, I heard everything, I wrote everything down, but, did I really kind of understand what I need to? Did I really grasp, everything that I need to? And so, I wrote these learning objectives in a way so that you can kind of, almost like kind of test yourself. And so at the end of today, you should be able to define what biomechanics is. And so if you aren't able to define biomechanics by the end of the lecture today, that's probably a good indication that you should probably go back and watch the lecture again. Okay. Okay. So a little bit about myself. So my name is Professor Justin Tran. So my office, it's a little bit in flux right now. So right now my office technically is in the computer science building, but I am moving sometime either next week or next week after that. So this office that I have right here, E220, that's my new office. But right now my office is actually CS 526. Yeah. And so if you're going to come to my office for office hours, right now it's in the CS building. And then I'll send an announcement once I've kind of moved to my new office. And so the plan was for me to move to the new office before the semester began, but some things got delayed, and so I wasn't able to move. Okay, so my email address is justran@fullerton.edu. I always tell people that it's very easy to remember because it sounds like you just ran a mile at Fullerton or something like that. Okay. I always joke with people that I think maybe I stole this email address from a running club here at Fullerton or something like that. But too bad, that's my name, and so that my name is more important than your running club. That's what I always tell people. Right? So I grew up around here. So I am from Southern California. In fact, I'm from Cypress. And so if you're not sure where that is, that's about, I think, maybe 8 or 10 miles west of campus, right down the 91. So I'm very familiar with the area. In fact, I had quite a few of my friends from high school went to Cal State Fullerton, and so I was very happy to get a job here. Right. A bit about my educational background. I got my bachelor's from UCLA, my master's from UCSD, my doctorate from Stanford, all of it in mechanical engineering. And my research interests involve, applying engineering tools for studying heart and blood disease, as well as STEM education. So, how can we, better, teach classes? Basically, that's what I'm interested in. Okay. And in terms of what you can call me, I'm not picky at all, and so you can call me Professor Tran. I think most people call me Professor Tran. I think that's what they feel most comfortable with. But feel free to call me Justin. Feel free to call me Dr. Tran, Dr. Justin, Professor Justin, just Justin. Anything that you want. I put this out every semester, and actually someone took me up on it last semester. But so I grew up in the era of online gaming, and so I'm no stranger to being called, dick face or, asshole, things like that. And so, you can call me any of those things if you want as well. But, it's also, as long as you say it with respect and say it, jokingly, then, I'm okay with it. Okay. So enough about me. Let's talk about the course. And so what is biomechanics, right? So you all signed up for this course. It's called Engineering Biomechanics. And so let's talk a little bit about what it means, okay? And so, everyone here is in mechanical engineering. And so, presumably, I figure everyone is familiar with the concept of mechanics. And so things like forces, moments, stresses, velocities, accelerations, right? So these are all kind of concepts that define what we know as mechanics, right? And so you probably learn mechanics from a Newtonian perspective. F is equal to ma, velocity is equal to acceleration times time, things like that. Okay. Biomechanics is basically the same thing, right? And so biomechanics is not that different from mechanics. The only difference is that we're applying it to biological scenarios or biological situations. Okay. And so in particular for this class, we're going to be looking at the mechanics of living system. and in particular, mostly for the human body, right? So how does the human body move? How does the human body, generate forces? How does the, forces on the human body affect joint health? How does it affect, how does it lead to injuries, things like that. Okay, and so I don't want you guys to think of biomechanics as something very exotic or very something that I want you to focus less on the bio portion of biomechanics, and I want you to think of it as purely just mechanics because at this point all of you are either in your third or fourth year, or I know a lot of you are graduate students as well. At this point everyone should have a very strong grasp of forces and motion and mechanics, right? And so I want you to think of this class as just applying those exact same ideas to biological systems, in particular the human body, okay? But the reason I think people think biomechanics is challenging is not really due to the theory, or not really due to kind of the mechanics, but it's more due to kind of what I call practical complexity. So things like irregular geometries, or maybe things like nonlinear material properties. And in some cases, sometimes we're dealing with several states of matter as well. Okay. Because one thing you'll see that's very different in this class is that, the human body, was not designed in SolidWorks, right? It was not designed to, be in convenient shapes. The human body is just kind of shaped how it is. And so, as opposed to kind of, I would say classical mechanics, where you have kind of more control over the geometry and you kind of shape it to be convenient in terms of calculations, in terms of manufacturing, the human body is what it is. And we kind of have to just kind of work around those geometries and apply what we know about mechanics to those geometries. Right? And so I think a lot of the difficulties that you'll have with this class will be kind of more in terms of geometries, more so than the mechanics or kind of the theory and and understanding material. Okay, so let's talk about kind of the broad areas of biomechanics. And so there's lots of different ways you can classify this, but this is kind of how I kind of organize it. And so I like to think of kind of three main areas of biomechanics. And so the first area is what I call performance. And so this refers to how living systems, very broadly speaking, how living systems do things, right? So things like walking, sitting, standing, throwing, reaching, swimming, all kind of typical actions that we do, and analyzing those actions in terms of forces and moments and velocities and accelerations. Okay. And so this can also refer to the kinematics of these things too, like blood flow, muscle mechanics, and joint kinematics. Okay. So in this class, we're going to focus, the majority of this class, I would say 85% of this class is going to be on performance, right? So taking typical actions, things like walking, and analyzing, what are the forces in the muscles, what are the forces in the joints that are needed to kind of produce this motion, as well as in terms of, the directions and the angles and the magnitudes of those vectors. Okay. The second area of biomechanics is what I like to call injury. And so this refers to either failure or damage to biosystems. And so things like broken bones, torn muscles, ligaments, organ damage and impairment. Okay. And so injury, we'll touch on injury a bit this semester as well. But to really kind of dive into it, you really need to know a lot about kind of the material properties of the bones and the muscles and the ligaments and things like that. And that unfortunately is a little bit outside the scope of this class. We'll talk about it kind of in general, but specifics kind of get pretty complicated. And so injury is kind of another area of biomechanics. And the third area, which we really won't delve into much at all, is rehabilitation. And so this concerns recovery from injury or disease, right? And so this can include a lot of different things. It can include design of assist devices or corrective devices, design of implants to put inside the body, design diagnostic devices, and as well as tissue healing mechanics. And so this area kind of right now is a lot more specialized. And so, for an introductory class like this, it's kind of hard to fit this in. But there's, that's definitely a big area of biomechanics, as you can imagine, especially in the realm of biomedicine. Okay. All right, any questions on any of this so far? Okay. Okay, so let's talk about some engineering applications of biomechanics. And so these are some examples that that previous students have actually studied before. in their final project. Someone asked me about the final project before the class, but we'll talk about it a bit more later. But I just kind of wanted to showcase some areas and applications of biomechanics that may be of interest to you. And so the first one, so this was a project from last year, actually. So what they did was they looked at the biomechanics of shoe design. And so, if you play any sports or even if you do any kind of athletic activity, you know that kind of the shoes that you wear have a big impact in terms of, the performance of how well you can perform in that sport, as well as preventing things like injuries and general soreness, right? And so what they did was they applied kind of the knowledge from the class to look at several different sports shoe designs, and how they affect the human body and why certain shoes are better than others for certain tests. Okay. All right, and so another area is wheelchair design. So I think this was a project from a couple years ago, and so what they did was they looked at basically devices to help those who are movement impaired, and so they looked at several different wheelchair designs, and they talked about kind of their general properties in terms of their design requirements and what they need to do in order to kind of best assist the human body. Okay. And so another area of biomechanics is injury rehabilitation. And so what you see here is kind of an external support device for this person. So this person may have lost the ability to walk. And so what you can see here is he has kind of support devices that kind of support his legs, as well as these kind of canes as well to kind of support his walking. And so this is a very kind of broad area of biomechanics that there's a lot that you can study here as well. Okay. Another really interesting area, that's pretty advanced is this idea of surgical robotics. And so, bioengineering is kind of, we're kind of almost in the middle of a big renaissance in terms of the biomedical field, because, we're really developing technologies that can really kind of change a lot of what we do in terms of patient care in the hospitals. And one area where, a big splash is being made is in these surgical robotics. And so, I think when people think of surgery, what the kind of the image that people usually think of is kind of the patient that's kind of laying down on the bed. And then you have a team of surgeons kind of around them, surgeons and nurses that are kind of manually operating on the patient. And so the idea of surgical robotics is that, instead of having, the surgeon, standing next to the patient operating with their hands, instead the surgeon is kind of standing, nearby or even maybe in another room, kind of operating on the patient through these kind of robotic arms. And so what these offer is, of course, more precision. And so these robotic arms can act with a lot more precision than a human hand. And it also allows the doctor to kind of do multiple things kind of at once instead of being limited by their two hands. And so this particular device is from, I believe, a company called Intuitive Medical. And so this is their kind of their flagship product right here. There's also a big area of biomechanics and injury prevention. And so, you're probably familiar with these devices that I have in front of you here, which are just simply bike helmets. And so, even relatively simple devices like this, there's a lot of analysis and there's a lot of, design that goes into these devices to make sure that they, protect the person as much as possible, without kind of inhibiting their movements a lot. And you can see, for different kinds of applications, whether you're, you're speed biking or maybe you're, doing something else, there's lots of different designs for helmets that are more suited for those things. And each of those designs, these designs are not just visual, the differences in the shape, offer different biomechanical properties as well. Okay. Okay, and so that's just kind of a brief overview. Some of those were previous projects. Some of those were kind of in areas that interest me. But I think what's really interesting about this class is that I think a lot of people come to this class with kind of specific areas of biomechanics that they're interested in learning. And so, I'm interested in hearing from you guys. And so you can either, turn on your mic and kind of say it out loud, or you can drop it in the chat and, we can chat about it for a little bit. And so, let me know what kind of areas of biomechanics are you interested in?
Prosthetic limbs, arms.
Prosthetics, that's a great one. Yeah, there's always at least someone every year that's interested in prosthetics. Yeah, prosthetics is a great area, and so in fact, it's one of the more quickly growing areas as well, because 3D printing is making a big splash in that area as well. And so, yeah, that's a great example, because most people are kind of fortunate enough to be born with, kind of the bones and the muscles and the joints to kind of, do everything that we need to. But prosthetics kind of gives a way for people who don't have those things to kind of participate in everyday activities. And so the question of, how do you best design kind of a prosthetic limb to kind of give you everything that all the same properties that a natural limb will give you, is a very challenging question, and I think one that doesn't have a perfect answer yet. And so that's definitely a great area to be interested in, and I think an area that's going to have a lot of exciting development in the coming years. Yeah. All right. So prosthetic legs, yeah, that's a great one. Robotic prosthesis, yeah. So robotic prosthesis, that's kind of a sub area of prosthetic limbs where you can control the prosthetics, using either robotic device or or other ways as well. Yeah, definitely great area. Ergonomics, yeah, ergonomics is a great area, and so something that I think a lot of people don't think about. And so whenever you're doing anything, one thing we'll talk about a lot in this class is that you're putting at least a little bit of stress on your body, whenever you do anything, especially when you're sitting for long periods of time, or you're standing for long periods of time, or you're typing for long periods of time, which is generally what people do for their jobs. And so how do you best design a workplace, or how do you best design chairs, or how do you best design, workstations to kind of fit the human body to kind of prevent these kind of long-term injuries is a very, very important question. And I think one that a lot of people kind of take for granted. And so, yeah, that's definitely something we'll talk about in this class. All right, let's see. Exoskeletons, rehabilitative or augmentative. Yeah, that's a very interesting area as well. So exoskeletons are kind of these kind of external devices that you can attach to your body to either give you support if you're rehabilitating from an injury, or there's even some that can even augment your abilities too, with either a motor or some kind of pneumatic or hydraulic device that kind of gives you more strength for certain exercises. And so I think there's been some experimentation with that in the military, to kind of help soldiers kind of carry heavy loads for longer distances and have them put less strain on their muscles. And so there's definitely a lot of interesting areas in that as well. Yep. All right, anything else? Bio-inspired robots, yeah, that's a great one as well. Yeah, so this is I actually I think becoming pretty mainstream now, and which is kind of taking inspiration from biology and then applying that to how we design devices and how we design robotics. Yeah. And so it's kind of almost the kind of opposite of kind of of traditional engineering, where you kind of design a device from scratch. Instead with bio-inspired design, what you're doing instead is you're looking at kind of a task, or you're looking at kind of a behavior that you want to mimic in a robot, whether it be flying or swimming or lifting, or jumping, something like that. And you look at certain animals or certain humans that are good at this, and seeing if you can take inspirations from that to kind of improve your robotics. Yeah. All right, let's see what else. Forensic engineering, yeah, very interesting area as well. Unfortunately, we're not going to get too much into forensics, just because that's a little bit more, especially if you're looking at the kind of the biomedical side, like the biochemical side. We're not doing too much on that. But what we are going to do is I think probably what you're referring to is, looking at maybe kind of the physics in terms of how certain accidents happen, or how certain injuries happened, and kind of almost kind of like back kind of figuring out how that may have occurred, depending on how bone may have broken, or how muscle has gotten injured, or maybe how a bruise located in a certain location, how that may have occurred. So yeah, definitely a very interesting area as well. Yeah, we're not going to go too much into it, but yeah, there's definitely a lot more there that we can do. Yeah. All right. This is great. So, I like to ask this at the beginning of the course, especially in an elective course like this, because in elective courses, I have a lot of freedom in terms of how I can design the course and what topics I choose. And so, hearing from you guys in terms of what you're specifically interested in a very broad topic like biomechanics, is great. And so now what I can do is that for the later parts of the course, I can try to fit in things like prosthetic limbs, things like exoskeletons, ergonomics into the course, because I know it's interesting to you guys. And so I love having these conversations. I love talking about these things. Yeah. Let's see, one more. So prosthetic tissues, yeah, very interesting topic as well. And so that's kind of getting into the realm of kind of more kind of um, you know, biochemistry. Because when you're talking about kind of artificial tissue, things that you're actually implementing into the human body, not only do you have to make sure the material properties are good, but you have to make sure that your body is going to accept it as well. Because what can happen, what the human body is very fascinating. And so, what can happen sometimes is that, if you put something foreign inside the body and your body rejects it, your own body could actually start to attack it. Actually, when I was in graduate school, I worked on a project to this about blood grafts. And so, a lot of people, especially older people, they have to get what's called a bypass graft. And so, if certain blood vessels in their body become diseased, or if they become, plugged up due to plaque or things like that, then you have to get an artificial blood vessel to kind of route blood, down to a certain part of your body. Because if your natural blood vessels are plugged up, then, certain parts of your body can't get blood. And if that happens in a very crucial area like your lungs or around your heart, that could mean death. And so, a lot of people have to get, bypass surgery in order to make sure that they can, get blood in the places they need to. But an issue that people were seeing is that, when you put artificial blood vessels, when you put artificial, anything inside your body, there's a possibility that your body might attack it. And so what happens to some patients is that, they go in, they get open heart surgery, they get a bypass graft, they're healthy again, they're doing great, but maybe like, 5, 6, 7 years down the line, then they start to have the same symptoms because the body recognizes that tissue that you put in is artificial, and it starts to actually attack it and kind of close it up again. And so, these patients are, they have the same issue again. And so, what I did in grad school was I worked on simulation to kind of, to simulate some of these things, to see if we can get some more data on it. But yeah, very interesting issue. Not something, that gets more into kind of the bio side. So, we're not going to get too much into it, but, there's definitely a lot there as well. Yeah. All right. Anything else? Any other areas of biomechanics that you guys are interested in? Yeah. And even if you aren't, even if you're coming into the course, without really any, strong interest in a particular area, maybe you're just curious about biomechanics, that's perfectly fine as well. And so, that's actually great. And so you can come into the class, with an open mind, and you can learn, basically at the same pace as everyone else. Yeah. And so, yeah, thanks. So thanks for sharing, everybody. And so, yeah. Okay, so let's talk a bit more about the course, right? And so just like I mentioned before, the main complexity or kind of the main reason why people find biomechanics are difficult is in kind of the irregularity of the parameters, right? The fundamental understanding of the science and the equations, everyone should be pretty familiar with. And in fact, we're gonna have a review day for mechanics, and probably most of you are gonna be like, yeah, that's easy. I know that force is equal to ma, right? But what's going to be challenging is actually applying this to biological geometries, which are very, very complex. Okay, and so what I have here on the right here, this right here is a computer rendering of your knee joint. And so what you have right here, this is your thigh bone, or at least the bottom of your thigh bone. Down here is your tibia. And so this tibia here is the kind of the largest bone in your lower leg. There's two of them. So there's the tibia and the fibula. And the knee joint is kind of the interaction between these two. And these other tissues that you see here are the various ligaments and soft tissue that kind of hold it together. And so right here is this is the MCL. And so this is a ligament that's on the medial side of your knee, the inside side. This is the PCL. And so you can see here, this is actually a simulation of an injury, where a case where someone's PCL actually detached here. And there's more ligaments on the inside as well. Okay. And so if you look at this geometry, it's you can't really describe it in a single word. So you can't really say that this is like, it's not really a square, it's not really a cylinder, it's not really a pyramid, right? It's kind of its own thing. It's a biological geometry, right? And so how you describe this, how we actually apply equations to this, is going to be really hard. And so it's not the easiest thing, right? And so, talking about, how do we simplify geometries like this? How do we actually put it in a form where we can apply equations? That's where we're going to spend most of the time in this class. Okay. In addition to that, not only are the bones themselves, very complex geometries, but if you look person to person, there's a large amount of variability in terms of the size and shapes of humans, right? So every human is different in terms of their shape, in terms of their size, right? And so, when you go to design devices for humans, you can't just design a device for just one person, because that one person is not going to pay your salary for the whole year, right? And so you need to be able to sell your device to a variety of people. And so, thinking about, how you design devices for a variety of people is a very interesting question. And so you can't just really design for the average, that's kind of what people tend to do. And so they look at kind of the average size, the average, geometrical properties, and they design around that. That's not going to work for most people. It's only going to work for, those people that just happen to be the average size or the average weight of the human race. Okay, and so in this class, we're also going to talk a lot about, what I call qualitative versus quantitative, right? And so, in this sense, this course is going to be, a bit different because we are going to run into situations where, we're going to have either too many variables or too much geometrical complexity, where we literally can't solve things, on paper. We either have to rely on a computer, or we have to simplify, the geometry as well. And so kind of, thinking about, how complex our models need to be, and, when to apply certain equations and when to simplify, that's going to be a big theme of this class as well. Okay. I do, if we have time at the end of the class, I would like to kind of show you guys a software that I like using for analyzing, biomechanics and human movement. And so actually last year I planned to show that software to the class, but we actually ran out of time. So I'm hoping that we can go a little bit faster this semester so I can show you. But if we don't get to it, then it's not the end of the world as well. Okay. Okay. So let's talk about an overview of the course. And so I've kind of broken down this course into kind of 4 big kind of sections. So we're going to start here on the left, and so we're going to start with an introduction to the course, which is what we're doing. As well as an introduction to anatomy, which is what we're going to do on Wednesday. Okay. From there, we're going to move on to what I call kind of general properties of the tissues, because those are kind of very important to kind of understand, when you're talking about biomechanics. And then we'll move on to static analysis, where we're going to spend a lot of the class in. And at the end of the class, we're going to talk about dynamic analysis, which is movement. Okay. And if you kind of, you can kind of break this down into kind of more kind of areas as well. Okay. And so, this outline here, it's good to know, just to show you that, I am organized. I'm not just doing random shit every day. But, of course, a lot of these things, a lot of these terms really don't really mean anything right now. And so, what I'm hoping is that, throughout the course, as we go along, you'll kind of refer back to this diagram, kind of see where we are on the roadmap. Okay. Any last questions about kind of that kind of concludes the introduction to the course. And so, hopefully by the end of that, you guys have a better idea of kind of what this class is about, kind of what you can expect to learn, and kind of how this class is going to go. But are there any questions about the course in general before we start going over the syllabus? Okay. All right. And so for the rest of class today, what I wanted to do was I wanted to go over the syllabus. And so I wanted to go over kind of my course policies in terms of what you can expect in terms of, the number of assignments, when the exams are going to be, how to contact me, things like that. So kind of what I call administrative stuff for the course. And then after this, what I'm going to do is I'm going to give you a tour of the course website as well, just so you can take a look. Because the main way, or at least kind of the main kind of resource that you're going to have for the course, besides obviously coming to lectures is important, is going to be the course website. And so I want to make sure that you know where everything is, kind of where I post everything, and kind of how to navigate that website. Because I think I do it a little bit differently than some professors. Okay. All right. Question. Let me check. Question. So I am waitlisted. Do you accept more students? Yeah. So for my technical electives, I try to add as many students as I can. And so I know that there is an official capacity right now of 35 students. And there are quite a few of you on the wait list. I think last time I checked, there were like eight or nine of you on the wait list. And so I am going to try to accommodate as many students as I can. My original plan was to have around 40 students in the class. But if there's strong interest in the class, I'll try to look to see if I can add, maybe 42, 44 students in the class. And so, I am going to try to make it work for everyone. But I do have to cut it off. And so I don't want 50. So 50 students is a little bit too much for the course. Especially because I think, we might have a restriction in the room. We might have to get a bigger room, for the course. But I'm going to try to accommodate as many students as I can. But I don't make adjustments to the course roster until the end of the first week, because what tends to happen in the first week is that students kind of tend to drop out on their own. And so, by the end of the first week, you'll know if you're going to be in the course or not. And of course, the higher you are on the wait list, the more likely you are. So, at the very least, I'm going to have at least 40, so 40 students for sure in the course. And then, depending on how many students past 40 I am by the end of the week, then I'm going to look to add more students. Yeah. But you're definitely welcome. Even if you're on the wait list, you're definitely welcome to attend the lectures this week. And you're, definitely welcome to, talk to me as well. Okay. And I think someone in the chat just dropped the link for the Discord server as well. So feel free to join that. I'm sorry, I think someone was speaking. Does someone have a question?
Sorry, yeah, I had a question. So is online, like Zoom, going to be optional, or is it going to be on every class?
Yeah, no, that's a good question. And so today was a little bit special because the campus kind of canceled all in-person meetings. So for the rest of the semester, I will be physically in the classroom, and so you can attend in person. But I will have the Zoom option available as well. And so, I know especially for a lot of the graduate students that, you have work schedules or, it makes it hard to kind of come to campus. And so, you definitely feel free to attend via Zoom. The only days that I am going to require everyone to be in person is for our exams. And so for the two midterm exams, you have to be in person for those. I'm not going to offer there's no option to take the exams virtually. But for all the other lectures, you're welcome to either attend in person or you're welcome to attend over Zoom. Yeah.
Thank you.
Mm-hmm. Okay. All right. So let's talk office hours first. And so, again, my office right now is not E220. And so I actually made these slides actually about a month ago. Because I was in Europe actually for the last 2 weeks. So I thought that I would have moved to my new office yet, but it's not ready yet. So right now my office is CS 526. Okay. But eventually I am going to move to 220. And so I'll let everyone know once I'm in the new office. But for right now, I am in CS 526. Okay. And so I have office hours 3 times a week. And so they're on Tuesday mornings. And so from 9 a.m. to 10 a.m. This is the only day where office hours are virtual only, just because traffic in the morning is terrible, and I like to avoid that when possible. So I will only be on Zoom on Tuesday mornings. But if you come to office hours on Tuesday, there is a Zoom link for that on the course website. Okay. I also have office hours on Wednesday from 5:30 to 6:30 p.m. And so this is both in person and virtual. And so if you notice that is directly right after the lecture. And so you're welcome to attend that one as well. And then I have office hours Thursday afternoons. And so Thursdays from 1 to 2 p.m. And that one also is either in person or virtual. Okay. And so if you plan to attend the office hours virtually, there are Zoom links for these on the course website, which I'll show you later. Okay. And so what are office hours for? So office hours are for, if you're confused about anything, and so if we went over something in lecture, and it didn't quite sit well, or if you're a little bit confused, office hours are a great time to kind of clarify those concepts. And so I'm always happy to answer questions during those. If you have questions on the homework, if there's a certain homework problem that's kind of stumping you, or if you're not really sure how to start, that's great for that as well. Or if you have questions about the exams. If you need tips on how to study, or if you want to get extra practice problems, office hours are great for those as well. Okay. But if you want to stop by and just kind of say hi and introduce yourself, that's fine as well. Okay. So I teach, I do advising, and so I teach a little bit less than everyone else, but I teach 3 different courses per semester. And so, you would think, for 3 different courses, there's a lot to discuss in office hours with my students, but, literally, more than half the time I'm just sitting in my office hours, just either grading or twiddling my thumbs, or, just waiting for people to come by. And so if you come by and just say hi and introduce yourself, it'll brighten my day a little bit, just seeing a person's face. And so definitely don't feel shy to do that. Okay. And like I said, I will be on Zoom for all of these office hours, and so if you're not able to make it in person, definitely feel free to attend on Zoom as well. Okay. Okay. Learning objectives. And so, we talked about learning objectives at the beginning of the course today, but I also have learning objectives for the entire course. And so, these are, objectives that, I hope you guys will all be able to do by the end of the course. Okay. And so you can read more about these on the syllabus, but I have 5 of them for this course. Okay. So number 1 is to identify and describe the mechanical function of the skeletal and muscular anatomy. And so you should be able to do that after Wednesday, actually. Okay. Number 2, to describe and quantify human motion in terms of mechanical variables. Number 3, to explain how human tissue responds to external forces. Number 4, analyze and model human motion for engineering design. And number 5, connect knowledge of mechanics and materials to biological systems. Okay. So when I went about designing this course, these are kind of the 5 kind of main objectives that I kind of kept in mind as I kind of designed all the course content in terms of the lectures and the homeworks and things like that. And so, you can almost think of these as kind of like the guiding light for this course. Okay. All right, homeworks and exams. And so I have 6 homework assignments planned, not including the first homework. And so the first homework, I think some of you have already completed, and so which is to send me an email. We'll talk about that at the end of the course today. Or at the end of the lecture today. So besides that, there are 6 homework assignments. There are 2 midterm exams and 1 final project. Okay. I have a policy in this course where I drop your lowest homework assignment. And so I know, things can get busy during the semester, especially with your other courses or if you're working. And so, I like to give you guys some flexibility in terms of, if you miss a homework assignment, or if you weren't able to, do all the problems on a homework assignment, I want to, give you the flexibility to know that it's your lowest one's not going to affect your grade, but at the same time, I would like everyone to do them all. So I don't, you're not going to believe me, and so you're not, maybe you won't believe my next statement until 2 years later. But when I give you guys work to do, when I give you guys homework assignments or exams to study for, it's not to make you busy, right? I try not to do things just to waste your time, because I believe that time is precious. And you should do things that are worthwhile with your time. And so, when I give you homework assignments, they are, I design them very, thoughtfully in a way to as a way to kind of reinforce the course concepts, or to give you practice with certain techniques, that you need, that are really important for understanding biomechanics. Okay. And so, you're not going to believe me. And so, I have students that tell me to my face, this homework was a waste of time. And I'm like, I know it seems like it, but, trust me, I give you these, I assign every problem, every question I give you with the purpose, to give you practice on important things. And so, please do them all. They're all important, but, if you drop one, that's totally understandable as well. Okay. Oh, if you're on the wait list and you don't have access to the Canvas, send me an email and I can add you to the Canvas site. Yeah. Okay, midterm exams. So the midterms will not be cumulative, and so the midterms each will cover maybe about 5 to 6 weeks worth of content. but there is going to be a pretty decent amount of content on each exam. Okay. So there's no final exam. And so instead of a final exam, there is a final project. And so the final project for this course, it's a group project. And so it's something that you'll do in groups of 3 to 4. And it will involve you doing your own independent research on a biomechanics topic of your choosing. Okay. And so you're going to write a report on it. You're going to do calculations. You're going to, read primary literature on it. And then you're going to present it to the class and write a report. Okay. Question. So the second midterm be on the 15th of November. Yes, that's probably a typo because I was making this kind of ahead of time. So yeah. So the second midterm probably is going to be on November 15th. Yeah, good catch. Thank you. Thank you for catching that. Okay. For the exams. And so there are no plans for makeups for the exams. And so if you can't make these exam dates, please let me know as soon as possible, just so that, we can make different arrangements. Okay. But the first midterm exam is planned for Wednesday, October 4th. And the second midterm exam is going to be on Wednesday, November 15th. Thank you for that. Okay. Both of those are going to be in class. And so like I mentioned before, for the midterm exams, you are required to come in person for the midterm exam. So please plan for that. Okay. And your final report is going to be due on Monday, December 18th. So that's actually the Monday after finals week. Okay. Okay. Any questions on this so far?
So for the final report, we're only turning in a report. There's no presentation or anything?
There is a presentation. So the presentations will be during the last week of course. Yeah. Yeah. So the last 2 lectures will be presentations. Okay. Any other questions on the homework and exams? Okay, course grades. And so I think I have a pretty standard breakdown for the letter grades. And so, after you've submitted all your work and I've graded everything, depending on your final course percentage, I will assign letter grades according to this scale. And so this is, pretty standard. One thing that I do a little bit differently is I do kind of I call it an adaptive midterm score grading. And so it's a little bit complicated, but, for the 2 midterm exams for the class, it happens every semester where, maybe you're not feeling well during the exam week, or maybe, you weren't able to prepare as much as you can. And so, I want to give you guys some flexibility in terms of the midterm scores. And so, for the 2 midterm exams, one of them is going to count for 30% of your overall grade, and one of them will count for 20% of your overall grade. Okay. The one that's going to count for 30% is whichever midterm exam you score higher on. And whichever one you score lower on will only be 20% of your grade. Okay. And so even, let's say that we get to the first midterm and you didn't do as well as you want. Okay. And so I want to give you the opportunity to kind of make it up by the second exam. And so if you do really well on the second exam rather than the first exam, the second exam is going to count for more, for your grade than the other one. Okay. And so it's a little bit complicated, but it's something that kind of happens every semester. And so I wanted to kind of give this opportunity to everyone and kind of have it kind of officially in the syllabus rather than something that's kind of, it's kind of more unofficial, which is kind of what's happened in the past. And so, that kind of explains why, this midterm higher is 30% and midterm lower is 20%. So, if you don't do well in the first midterm, it's not the end of the world. You can kind of make it up by the second midterm. And, the final project, of course, is a huge portion of the grade as well. Okay. All right, textbook. And so the textbook is not required. And so I think it's been just about 10 years since I've graduated from college, and I still have resentment towards the textbook industry for how much money I wasted on textbooks when I was a student. And so that resentment is like kind of part of who I am right now. And it kind of defines who I am. And so, I don't want to feed the textbook industry more money than it needs to. Okay. And so, the textbook's not required. But the one that I use for this class is this one right here. So it's written by Scott Delp. So this is someone I've met before. So he's a great guy. And so it's called Biomechanics of Movement. Okay, so it's in 2020, published by MIT Press. Okay. And so if you want to get a hold of the textbook, definitely feel free. But it's definitely not required. And so I'm going to post all the lecture notes for the course. I'm going to post the full problem statements on all the homeworks. And so you don't need the textbook for anything. But if you want to kind of learn more in depth on certain topics, the textbook is great for that. And so, that's there for you. Okay. And even better if you are able to find another version of the textbook online that is either cheaper or from another source, go for that as well. Okay. There is another textbook that I use, but this is a free PDF that's available online. So actually, I actually just post this online for everyone to use. So this is also on the Canvas course. Okay. Okay. Course website, and so we'll go over the course website in more detail in a bit. But your course website should kind of be your first, kind of your main hub for everything about this course, right? So basically, any content that I produce for the course, whether it be the lecture notes or the lecture slides, the homework assignments, homework solutions, exam solutions, study guide, tutorials, handouts, everything that I produce, I put it on Canvas for you. And so, definitely, it definitely will pay for you to be familiar with the Canvas site and to kind of visit it frequently, because I update it, at the very least once per week. Okay. I also send announcements on through Canvas. And so, those will be emailed to you if you're part of the course. I know if you're waitlisted on the course, you're not getting the announcements, but, I've only sent one so far, and so you're not really missing out on much. But if you want to be added to the Canvas site, send me an email and I can let you in. Okay. I also made a Discord server for the course. And so this is something I started over the pandemic where we didn't have a physical classroom. But, I wanted to kind of have a space for you all to kind of interact with your classmates, interact with your peers, organize study groups, ask questions about the homework, anything like that. Okay. So, I've created the Discord server, and you're free to join it if you click on the link. It's not a requirement, and so you don't have to join the Discord server, but, it's definitely nice if you do. Okay. And I really want that Discord server to be kind of a space for you guys. And so I'm going to do my best to be active on the Discord server, but it's really for you guys to kind of discuss on your own. Okay. And so this last point here is really important. And so because since Discord kind of became a thing, a lot of students kind of message me directly on Discord. And so you can do that. And so I'm not going to hate you, or I'm not going to chastise you for doing that, but but please save this for emergencies. Okay. And so kind of what's happened in the past is that students have kind of messaged me on Discord kind of at all hours of the day, and kind of expecting a response kind of immediately, just because it shows that I'm online on Discord. And as you can imagine, this was not great for my personal life. And so you can message me on Discord, but but please only save this for emergencies. Okay. If it's something I need to look at right away, or if it's a deadline that you need to ask right away. Okay. And so if it's kind of a general question on the homework, or if it's a general question that can wait, I would either ask that you use the questions channel on the Discord server, or you can email it to me, and I'll get back to you, at my, as early as I can. Okay. Okay. Course policies. And so homeworks. And so I do accept late homeworks, just because, I know that, you guys are busy and sometimes it's hard to meet, all the deadlines. But I do have to take a penalty. And so my policy is that each day that the homework is late, and so each day that you submit it after the deadline, I'm going to dock 10% off of its points. Okay. And so I usually leave the Canvas submission open for a week after the homework is due. And so, but if for some reason that's not open, you can always scan it and email it to me as well. Okay. Regrades. And so I do regrades as well. And so, I make mistakes when I grade things on homeworks and exams. And so I'm always happy to look at things again. But please let me know, within a week. Okay. And so, this is kind of to avoid the situation, which, even though I've had this policy for years, it happens every semester anyway, where we get to the end of the semester and, and you need a bump in your grade, and you ask like, oh, can you raise my grade for homework 1? Can you look at my midterm 1 again? And so by that time, it's kind of too late, right? And so when I grade things, my expectation is that you're kind of looking at the feedback, you're looking at the grade kind of somewhat, immediately, right? The reason for this is that, I try to grade things in a relatively timely manner. And so, usually a week after something is due, I'll try to get the grade back to you, and I'm hoping that you're kind of looking at it, right then and there, right? Because, feedback is great, but feedback is really only useful when you're kind of, still in that moment, right? If you're examining feedback for something that you did, 3, 4, 5, 6 weeks ago, it's not really useful because you've kind of moved on in your life, right? And so, to kind of help with that, I want you guys to be looking at the things that I grade for you, within a week. And if I make a mistake, then you can come ask me, right? And so after a week, after a week, past a week after I've returned something to you, if you want me to regrade, most of the time I'm not going to look at it, unless it's an egregious error. Okay. All right, emails. And so if you are going to email me about the course, please include, EGME 441 in the subject line. And so you can put it in square brackets, or you can put it, somewhere in the subject line, just so that, I know that this question is from this course, right? And so like I mentioned, I'm teaching 2 other courses, as well as doing advising. And so, my email address can get pretty cluttered, or my email inbox can get pretty cluttered. And so if you put EGME 441 in the subject line, then I can kind of know right away that, your question is for this course. And it helps me kind of organize my inbox, and it helps me kind of get back to you faster. Okay. And most of the times, I'll get back to you within 48 hours, a lot of times, within 24 hours, except on weekends, of course, because sometimes weekends I'm kind of busy with stuff. Okay. Okay. Let me pause here for a second. So are there any questions on these policies here? Okay. All right, graduate credit. And so if you are a graduate student taking this course, technically it's a 400 level course, and so this is a undergraduate course. And so in order for you to get graduate credit, then the university policies state that you must do an additional assignment. Okay. And so the extra assignment, what that's going to be is kind of your own little research project. And so I'm going to have you look into a research article or a scientific paper regarding biomechanics or a certain area of biomechanics. And I want you to read it, I want you to annotate it, and I want you to kind of write me a summary of that paper. Okay. And so I have a list of the graduate students. But if you're an undergraduate student and you're planning on taking this for graduate credit, please let me know as soon as possible, because there's a form, for me to sign. So if you're an undergraduate student taking it for graduate credit, there's a form, and so please let me know as soon as possible so I can sign that form. If you're a graduate student taking this for graduate credit, there's no such form, so you don't have to worry about it. But but just letting everyone know now. Okay. All right, academic dishonesty. And so, I usually don't like talking about this, but it needs to be said, right? So academic dishonesty will not be tolerated in this course. And so, academic dishonesty can mean things like, copying your solutions from someone else, posting the questions on some kind of online forum and having someone else do it for you. I've seen people pay other people to pay to complete their assignments for them. Nowadays there's AI, and so using AI to complete your assignments or to write your report, all of these count as anything that involves you not doing the assignment yourself or doing the course content yourself counts as academic dishonesty. Okay. And so committing academic dishonesty, at the very least will result in a 0 on that assignment. And if it occurs in something like on an exam or on the project, that can result in an F for the course, as well as a referral to student conduct. Okay. I don't like doing this, but it happens every so often. And so, it's kind of unfortunate, but it's kind of what we do or what we have to do. Okay. And so the reason for this is that if you're not fully engaging in the course content, if you're having something else or someone else do it for you, either by copying the solution or having AI do it, at the end of the day, it takes away from your learning, right? And you're in this course to learn, right? You're not really here just to kind of check something off on your transcript. And so what I hope is that everyone here is here to learn about biomechanics, right? And so if you ever feel like you're kind of struggling in the course, either you have time constraints, your other classes are kind of taking up too much of your time, or if your work schedule has been crazy and you're not able to commit enough time for the course, or if honestly, I've had students that come up to me and said, honestly, I haven't been putting in the effort for the course, but I really want to do well. Is there anything I can do, right? I promise you that if you ever come to me for that, if you tell me you're struggling, I'm not going to judge you, I'm not going to criticize you. that's not my job, right? My job is not to kind of, my job is not to make you feel bad. And I hope I never, reach a point in this class, where I make you feel bad. Okay. I want everyone in this course to succeed, and I want everyone in this course to learn, as much as they can from the course, right? Um, I feel like that's what my job is here to do, is to kind of help everyone succeed, right? But at the end of the day, if you're cheating, if you're copying, if you're using AI, you're not learning, and you're not kind of putting yourself in a position where I can help you. Okay. And so before you even think about doing things like that, before you even think about, committing academic dishonesty, please come to me first, and I promise you, I'll do my best to kind of make something, make it work for you, and kind of make a plan for you to kind of help get you back on track for the course. Okay. Yeah. And and it happened as recently as last semester. And so last semester, I taught a course where students used AI to write the final report. And you may think that AI is pretty good, and that it can write your final report, but for me reading these reports, it's actually very easy for me to see which reports were written using AI or not, right? So I would rather not be in that position again, this semester. So please, please, if you feel like you're struggling, let me know, and and I promise I'll do everything I can to help you. Okay. Okay. And so the last thing I want to talk about before I show you the course website is the first homework assignment. And so I call this homework 0. And so these are just email introductions. And so I just want you to send me an email to introduce yourself, right? And so, if you send me an email, I'll give you full credit just for completing, right? So everyone starts the course with an A, okay? And so, I want you to include your name, your year, and your major, okay? At the very least, just so I can give you credit for it. And you can talk about anything you want in the email, but if you have problems thinking about what to write, I have some questions here that can kind of help guide your your email. And so you can talk about what kind of career that you'd like to have after graduating. You can talk about what you would like to learn most from this course. You can talk about any worries or concerns that you have about taking the course, and just what are your interests and hobbies. Okay, so you don't have to answer these questions, but if you want to use them as a guide, then feel free to do that. Okay, and if you send me your email by this Sunday, August 27th by 11:59 p.m., then you'll get full credit for it. Okay, and don't forget to add EGME 441 in the subject line. Okay? All right, any questions on this before we go to the course website? Okay. All right, so let's take a quick tour of the course website before I let you guys go for today. Okay. All right, so this is the Canvas site, and so again, if you're not part of the Canvas site, then send me an email, and I'll add you to the course. Okay. And so this is the course here, the website, right? So we have the title of the course, we have the description of the course, we have the syllabus, and so you can download the syllabus. And so, we went over everything today, but if you want the paper version, here it is. Of course, I think there's still a typo here for the second exam date, so that should be November 15th. Okay. So I'll go ahead and fix that after today as well. Okay. The second textbook, the one that I mentioned for the PDF, you can download here as well. We're not going to need that for a few weeks, and so once we do start doing things from this textbook, I'll let you know. Okay. On the homepage here, you'll see links for all the Zoom stuff, and so you'll have the Zoom link for the lecture, which all of you have figured out because you're here. We have the Zoom link for Tuesday office hours, Wednesday office hours, and Thursday office hours, as well as the link for the Discord server. Okay. Okay. And so at the bottom of the homepage, this is what I call the course outline. And so you can see here that I've kind of broken down the course into the 16 weeks that we have together, okay? From the first week all the way until final presentations, right? And as we go throughout the course, these will become clickable links that you can click on to see, what's going on for that week, okay? So let's click on week 1 so we can kind of see what's going on here, right? And so inside each of these weekly pages, and so you can see this is the page for week 1, you'll see that I've written kind of the title for the week, kind of what we're going to cover. I've written a description, kind of based on what we're going over for that week, as well as the learning objectives. Okay, so these are everything that we're going to go over this week. Okay, because I'm streaming all the lectures on Zoom, I am recording all the lectures, and so I do post the lecture recordings on YouTube, and you can view the recordings here. So after the lecture today, I'm going to upload this lecture onto YouTube, and you'll be able to click this link here for the recording. Okay, and after Wednesday's lecture, you'll be able to click this one as well. Okay. Here you can see links here for all of the assignments, and so there's homework 0. This is for introductions. Okay, and so this is due by August 27th. And you can see here I've actually posted the first real homework assignment too, which is anatomy and tissue biomechanics. And so this one is due on September 6th. Okay. And so you won't be able to do this yet because we haven't covered any actual real content for the course, but I did want to prepare this and have it ready for you guys in case you want to look at it. Okay. And so the last thing you'll see on each weekly page are the files. And so all the lecture notes for the week, I'm going to post here as well. And so you can see here we have 2 lecture slides. And so we have the introductory slides that I just went over, as well as the slides for Wednesday, which is going to be on skeletal and muscle anatomy. Okay. All right. And so I usually have these up. I usually have these weekly pages up the Friday before the week. And so the page for week 2 will be up sometime this Friday. And so definitely I would check these just to either, just to download the lecture notes for the week, to look at the assignments that are due soon, as well as kind of checking out kind of the topics for the week. Okay. And if you miss a lecture, or if you want to see the recording from a previous lecture, I've organized this in a way so that you kind of, go directly to that link. And so, let's say that you missed a lecture on Wednesday. And so, you can go to the week 1 page and click on this link here, which will be clickable soon, to view that lecture. Okay. All right. Any questions on the weekly pages here for the course website? Okay. All right, so the next tab that we're going to look at is the announcements. And so these are all the announcements that I've made for the class. And so if you're part of the Canvas site, you will receive these in an email. But if you wanted to see a summary of those announcements, or if you deleted the email by accident for some reason, you can come here and read the announcement again. Okay. The next tab here is the assignments. And so you can see all the assignments that there are here. Okay. In particular, you can see when the assignments are due. Okay. Okay, so this part here gets confusing for people, and so I want to make sure I make this clear. And so, the assignments have 2 dates here, and so there is one date for the availability and one date for the due date. Okay, the assignment is due on the due date. Okay, but I leave the assignment open for a week after the due date, just so that you can submit it late if you want. Okay, so that's why you see the availability date is a week after the due date, right? But it's due on this date right here, right? And so, despite me saying this, it happens every semester that a student will submit an assignment a week after it's due, and they'll say that, oh, I got the 2 dates confused. And so, it's due on this date. It's not due on this date. The only reason I have this here is so that you can submit the assignment late if you miss the deadline. Okay. Okay, so the next tab here is for your grade. And so you can see all the grades that for the assignments here, as well as kind of a breakdown of your total grade. This is a typo here. I need to change this to 10. And so you, at any point in the course, you can kind of see how your grade is doing. Okay. We have a tab here for people. And so if you're curious about the names of the people in the course, you can look it up here. I think you can click on them to see their contact info if you want. Okay. And the last tab here is for files. And so this is kind of like the Dropbox folder for the course. And so any homework assignments, any homework solutions, and all the lecture notes you can find here as well. It will all be here. Okay. All of these files will be linked on the weekly pages. And so, if you're following along in the course here on the weekly pages, probably you won't have to go to the files tab. But if you're looking for a particular file, if you're looking for a particular homework solution or a particular lecture note, you can close the files section there. Okay. Let's see. All right, we have the room location here and the time, as well as my email address. I think I still have this as well. Yeah, this is like my Tinder profile for teaching. Okay. Okay, all right. And so that's the course website in a nutshell. And so, again, the main things is that, you should check the weekly pages, and you should know where the Zoom links are. Okay. All right, any questions on this? Okay. All right, so that's all I had planned for today. And so on Wednesday, when we come back, we will start on our lecture slides for skeletal and muscle anatomy. I was thinking about starting at day, but we have 8 minutes left, and so we'll just end a little bit early. So thank you guys for coming today. And thank you guys for meeting virtually. And hopefully you guys are staying safe from the hurricane. And so on Wednesday, I should be in the classroom, but you can attend on Zoom on Wednesday as well. Okay, so have a great day, everyone, and thank you for coming.
Thank you.
Thank you, Professor.
Thanks, everybody.
Thank you.
Hi, Professor. Can you hear me?
Yep, I can hear you.
Hi, Professor. I have you for tomorrow's class. Is it fine if I can combine the homework zeros into one email?
Oh, of course. Yeah. Just have both classes in the subject line, and you can just write one email for that.
Okay, got it. Thank you, Professor.
Yep.
Hey, Professor, can you hear me?
Yep.
Sweet. Um, so I just want to let you know I might be late a little bit on Wednesday, more so
Okay.
because I recently injured my knee
Oh,
playing
okay.
basketball.
Oh, man.
I'm pretty sure it's an ACL.
Ooh,
Um,
dang.
so I've been crutching around. I have a dining appointment with the ortho tomorrow,
Okay.
but either way, I just thought I'd let you know in case I arrive a few minutes late
Okay.
to your class. And
Okay.
I don't
Yeah.
know even if it is an ACL, I might miss a few weeks of in person.
Okay. Yeah. It's no problem at all. I mean, and that's part of the reason I have the virtuals, just so because I know like life stuff happens, and so that's why I have the Zoom option, and I have the recording so you can catch up. But yeah, not a problem at all. But thanks for letting me know, and
All right,
I hope your knee feels better.
Thank you, thank you. If anything, I guess I just did the final project already on my knee.
That's a good, yeah. No, the knee is fascinating, and in fact, I actually know a lot about the knee as well because I actually injured my knee in high school as well, and my dad actually tore his ACL playing basketball as well.
Oh,
And so yeah, I learned a lot about the knee just going to the orthopedist with my dad a lot too. So yeah,
well,
ACL is a brutal injury, so hopefully you didn't tear it. So yeah.
yeah, well, that's what I'm thinking, but I don't know. It doesn't look right.
Oh man, well yeah, hopefully it's not too bad.
Yeah. All right. Well, I'll see you Wednesday. Thank you,
Yeah.
Professor.
Yep. See ya.
I do have a couple of questions, Professor, and one
Sure.
comment.
Sure.
I'll start with the comment. Thank you for organizing the class. It's honestly, it looks really simple and I like it. I feel
Great.
like it's going to be very useful.
Awesome. Yeah. Glad to hear.
Another question is, so usually when we have our like midterms, are we going to have like a review midterm before, or are we just going to review notes and problems?
Yeah, so for the midterm exams, I always give a study guide for the exam to kind of help you review. In terms of practice problems, I usually tell students to kind of review the homework assignments. And so the homework problems, the way I kind of write my homework problems and exam problems, I write them very similarly. Um, and so, what I tell students that if you can do the homework problems really well, then you can do the exams. This is the third time I'm teaching this course, and so I know students have typically asked me for practice midterms, and so what I can do is I can post the midterm from the previous year to help you study as well. Yeah.
Okay, thank you.
Mhm.
Second question is, so you said that we're okay just by reading your notes, right? We don't necessarily have to get the book.
Yes, correct. Mhm.
Okay, then. And my third question is, so I was fortunate enough to get a internship a couple of like a week ago.
Great.
So
Congrats.
thank you. So they do want me to work a certain amount of hours. Are you okay if I'm virtual most of the time, or at
Yeah.
least if you want me to be in person, I can come in late? Because if I do end up working 8-hour shifts for 4 days a week, I probably wouldn't be able to make it to class till like 5, or at least
Yeah.
see your videos after.
Yeah. No, I mean, you can attend, almost the entire course virtually if you want, except for the midterm days. And so,
Yeah,
I've
of course.
especially for grad students that are working, that ends up kind of what they end up doing. And so, I had a student actually last semester that was not even in California and completed the course. But that course didn't have any exams, so he didn't have to be here. But yeah, it's totally fine with me if you attend virtually for most of the semester.
Yeah, I just wanted to make sure before you just there's like an empty seat or whatever, I don't
Oh
want to
yeah,
have any kind of conflicts between not being able to attend school.
for sure, for sure. Yeah, no, and I think the internship will be a great opportunity for you. And so, definitely we'll make it work with the course.
Okay, then. Thank you so much, Professor. That was it.
Yep. Mm-hmm. All right. Any other questions for the course before we wrap it up for today?
No, Professor, that's probably for mine. Just a quick question though. For the tomorrow class, is it like online as well? Do you provide the Zoom link for the class or you in person?
Yeah, it's available online as well. So it's the same Zoom link, and so the same one that you're using for today. Yeah. Oh, I mean for are you're in one of my different courses tomorrow?
Yeah, yeah.
Oh yeah. So that one will
Okay.
be online, but the Zoom link for that is different. So for that one, are you on the wait list for one of those courses?
No, I'm already enrolled in the
Okay.
on-site.
Okay. Yes, yeah. So yeah, if you go to the Canvas site for that particular course, the Zoom link will be different, but it will be offered virtually as well. Yeah.
Thank you very much.
Yeah. Mm-hmm. Okay. All right. So I'll see everyone on Wednesday.